All right. This is our unit on matrices. First, definition of a matrix. It's an array of numbers and guys, you can stop and ask questions during the process, that's fine. An array of numbers arranged in rows and columns. Placed in brackets. Okay. Usually named by a capital letter. So matrix A. And this one is going to be a 2 by 3. It's always going to be rows by columns. So let's store some data. We'll store some data in here. 1, 2, 3. Okay. Give me the bottom row, Drew. What do you want on the bottom row? Oh, how creative of you. You copycat. That's what I already had on my sheet. 1, 2, 3, 4, 5, 6. Okay. Now, when you talk about the order, also called dimension, not dementia. Okay? The order or dimension of a matrix has to be rows by columns. And if we ever have any trouble with that, remember columns are like the Greek columns, right? Greek columns are up and down, so rows have to go across, right? So let's do the dimensions of this matrix. Lovely Haley, how many rows do we have going across? 2. And lovely Haley, how many columns? 2. Very good. So it's a 2 by 3. Okay. Elements. Are the numbers inside the matrix. All right, so how do you denote an element? Because it's matrix A, you use a little a. I'm going to move this up for you guys. And then we're going to write 1, 2. So this means the element in matrix A that's in row 1, column 2. And tell me if you ever need me to zoom in too, guys. I can zoom in. So the element in matrix A, so it's a lowercase a for matrix A. I'm up here. And it's row 1, column 2. So Joel, if we go back up here, what's the element in row 1, column 2? So what number is it? It is the number 2. Very good. All right. Nothing mind-boggling so far, gang? All right. Equal matrices. Must have the same order. And corresponding elements must be equal. So let's put in an example underneath. Let me give you matrix A. The elements in matrix A are x, y plus 1, z, and that's my German z, otherwise my z's look like 2's, and 6. Equal to matrix B. 1, 5, 3, 6. Okay, directions are solve for the variables. First, we have to check order. Remember, order has to be the same, okay? So Hannah, if we're looking at the first one, how many rows, how many columns?
2 rows. Columns, you said?
Yeah.
2 columns.
2 columns, very good, okay? All right, Max, matrix B, how many rows, how many columns?
2 by 2.
2 by 2. Okay, Miss Rachel, is order the same? Yes. Okay, so we're good to go. So all we really have to do is match up the elements now. Okay, so let's start with x equals, then y equals, then z equals. Okay. X is in row 1, column 1. So it has to match up over here with the element, Mason, in row 1, column 1. So what's the element in row 1, column 1 in B?
1.
It is. Excellent job finding that elusive x, Mason. Okay. Maya, y plus 1 is in row 1, column 2. So what element in B is in row 1, column 2? Very good. So, oops, I'm sorry, there should not be there. Y plus 1 equals 5. Master solvers that you are, let's subtract 1, and y comes out to be 4. Good, guys? All right, awesome. And Nat, the last one, z.
Equals 3.
Z equals 3. Good. So row 1, column, I'm sorry, row 2, column 1. Row 2, column 1. So z equals 3. Row 2, column 1. Not too difficult thus far, guys? Okay. All right, excellent. I'm going to flip it over, and we're going to do adding and subtracting, which is kind of what you did on the activity already. So shouldn't be anything too mind-boggling. Adding and subtracting. Matrices. Cannot add or subtract if you don't have the same order. So have to have the same order. I think we're pretty good at adding. I think we're just going to jump to a subtraction one. Okay, guys? So letter A. First matrix is 5, -3, 7, and -4, 8, 5, -3, 7, 4, 7, 1, minus second matrix, -4, 6, -5, and 8, 0, 3. Thank you. You're like an angel from heaven with a graphing calculator. Okay. The only reason I want to do a subtraction one, guys, is never do subtraction. So don't ever do subtraction. Change the operation to addition, and then change all the signs of everything inside this second matrix. So change subtraction to addition, and change all these signs. So positive, negative, positive, negative. 0 has no sign, so we're not going to change it. And then -3. First of all, Jasmine, what's the order of each of these matrices? Pardon? 2 by 3. So going across, how many rows? So going across, 3. And how many columns? Did you say 2? Thank you. All right, so does order match? Yes, it does. Final answer should also be a 3 by 2. And now all you have to do, guys, is add the corresponding elements. So take a moment and add the corresponding elements. Go. All right, Nat, you got it?
All right, going from top to bottom on the left side.
Okay.
9, -9.
Are you going across?
Oh, no, not across.
So go across for me.
Oh, go across? Okay.
Yep.
9, -12,
Yes, ma'am.
-9, 7,
Mm-hmm.
12,
Mm-hmm.
-2.
Mm-hmm. Now, guys, just for grading purposes, these matrices questions add up to a huge amount of points. This answer would be worth 6 points. 6 numbers in the matrix, 6 points, okay? Half a point for signs. Half a point for signs, okay? The only other thing we're going to talk about today then is called scalar multiplication. And that was on the activity when you had to find the average, okay? So scalar multiplication is defined as taking a scalar k times a matrix. We're going to make it a 2 by 2, and we're going to be very creative. A, B, C, D. So scalar multiplication is like that property we talked about on the algebra review. So what do you think you do with that k? What's that property from algebra 2? What do you think you're going to do with that k? So you're going to, pardon? Distribute it. Very good. That's all we're going to do is distribute it. So we're going to get KA, KB, KC, and KD. Very good. That's all scalar multiplication is. Okay. Let me give you, let's run through an example. Matrix A is going to be a 2 by 2, 2 rows, 2 columns. -1, 4, 3, 0. Matrix B is going to be a 2 by 2, 2, -3, 5, -6. Okay. First thing we're going to do is find -5 times B. Find -5 times B. If I asked you to show work, and I know you guys are going to say I can do mental math with this, that's the only work you would show?